Mr. Kane here, and welcome to a video clip all about the Bunsen burner. This is a bit of a coming of age for many science students as they first venture into the world of doing experiments and heating things up. So we need to learn all about this device here. They all should look pretty similar to this one, although sometimes they do have some variations in about the mechanism that opens and closes the air hole, this thing that you can sort of see here at the base of it. Sometimes it's a twist device like this one here, or it can be a little screw one as well. But we'll get rid of that and we'll carry on with our journey through the world of the Bunsen burner. But first, I want to tell you a bit about the guy that invented it. This guy here, Robert Wilhelm Eberhard Bunsen, German guy, born sort of in the, as you can see there, 1811. Grew up, went to school, typical lad it seemed like, and then at the age of 17 he went off to university in a place called Göttingen, and that's quite a special thing. He must have been a pretty special lad, because not many people today go to university when they're 17. But what was even more special was that by the age of 19 he had won an award for his work on a humidity meter, written it up, and awarded a PhD in chemistry. Yeah, he was a doctor in chemistry at 19 years old. Most people take about 3 to 5 years to get the degree they're going to get, depending which degree they're doing, and then another 2 to 3 years on top of that. So he must have been pretty special, pretty clever. Fitting with the town, there's a sign from the train station in town, and underneath it says Stadt die Wissenschaft, which translates into City of Knowledge. The university is still there today, so it looks like now. He started working there a couple of years after getting his PhD. He was 22. He didn't get paid by the university, but he must have got paid by the students he was helping out, and he gained his license to teach around then. And he had a reputation of being a pretty fun person to be around. I don't think he looked this tidy all the time. He had a reputation of maybe being a bit scruffy, not too careful about how he looked. And I think he said that he had better things to do with his time than worrying about clothing and stuff. But must have been a fun guy to be around. And there is reports that he must have made quite an impression on the ladies. However, yes, she'd have to give him a wash before she wanted to give him a kiss. He did all sorts of work with all sorts of things. One of the things he worked with was stuff called arsenic, and that's prone to other compounds. They can spontaneously explode, and he did all sorts of stuff into geysers and all sorts of places. But yeah, like I said, he was a fun guy to be around. This English scientist who he worked with as well said he was also really good to be around in the classroom. So what did he get up to sometime in the classroom? Like I said, he worked with arsenic. So you may know it as a poison. Yeah, it is quite a poisonous thing. And he worked with another guy, Arnold Berthold, and he discovered that there was an antidote to this arsenic poisoning, and did quite well with that. Got him on his way into the world of science. However, sometimes they are explosive, and they can explode just in dry air without warning. They just go off. Some time after that, he invented the Bunsen battery. It was a zinc carbon battery. Replaced the very expensive ones using more expensive metals of the day, and he combined his into large units, and was able to do all sorts of experiments with those large units of batteries. It sort of opened the world of electricity to a lot more people, having this cheap battery that people could use. He was able to analyse gas and helped industry. It sort of made smelting furnaces a lot more efficient to being used. He went to Iceland and he lowered things down to geysers and discovered how they worked as well. He seemed to love the dangerous, explosive side of life. There was some time later after his original arsenic cure that he actually needed it, because some arsenic compounds exploded in the lab and poisoned him, and it actually blinded him in the eye, and he needed his own antidote for the poisoning. This is in the time before the Nobel Prize, which is now the most famous prize for science. At that time, this medal here, the British Royal Society's Copley Medal, was the equivalent of today's Nobel Prize, and he was awarded that. In case you're wondering why a German scientist got the British award, this is way back before the wars, of course, and at that time scientists from all over the world collaborated and shared information and worked happily together. The wars changed all that for quite a long while, and we're now just now getting back to where scientists are working more happily together. He worked with a thing called the spectrometer and discovered new elements. Okay, spectrometer uses just a prism. You may get to see that during the year and play with light and create rainbows. It takes in white sunlight and changes into all the colours of the rainbow. This was first done by Sir Isaac Newton back in 1666. Years later, this guy William Hyde Wollaston repeated Newton's experiment, but looked at it through a magnifying glass and discovered lines within the spectrum. A while later, Joseph Fraunhofer looked at it even more greatly magnified and saw lots more lines. He saw about 500. Still doesn't know what they were for though. He worked with his work led to our work with fireworks, what we now know of colours. He had seen that sodium compounds give an orange-yellow flame, and this is where the Bunsen burner comes in. Okay, so these different colours are caused by different chemical compounds burning, and Bunsen saw this, but he also realised that the colour of the flame could interfere with the result, so whatever flame we were using could alter the colour, and therefore they wouldn't know what they were looking at. So he created the Bunsen burner, and it was the mixing of the air with the gas to create a colourless flame that was the big success of the Bunsen burner. It then didn't interfere with the results from the spectrum thing. He was working with a spectroscope. So he worked with another guy called Kirchhoff, put together the Bunsen burner with the spectroscope together, and they were able to observe other elements emitting a spectrum that now we use as like a fingerprint to identify these elements. So there's hydrogen, there's a more complex one, that's iron. So as these elements are burned or heated in a flame, they emit a colour. We trap that, it goes through the spectroscope, and we see these coloured lines, and it is like basically a fingerprint of the element. And this is how we can look at distant stars and learn about what is actually in those stars. And it's a new science, and it was created through the use of the Bunsen burner. He invented flash photography as well, using magnesium, and we met this guy before, Henry Enfield. They worked together. The intense bright light from burning magnesium creates the flash for photography. Also potential for explosions, and later on there was another explosion. With his work with the light and the spectroscope, Bunsen also discovered two new elements, cesium and rubidium. They actually themselves are quite explosive elements. He seemed to enjoy, maybe, I don't know, seemed to be involved with a lot anyway, these explosive elements and things. So let's get on to the Bunsen burner. Here's that back again. Let's look at the key parts to it. We have a nozzle. That's the part up here at the top. Okay. What's next? The barrel. Okay. This is the barrel here. This whole thing up and down here is the barrel. Alright, what's next? The collar. That's the part at the bottom that twists around this part here. That part there that you twist around to adjust the flame. The air hole. Be careful how you pronounce that. That's the air hole in there. And adjust the collar turns to adjust the amount of air coming and going from the Bunsen. Let's not get too messy here. Base, that's the blue thing that it's sitting on. and we'd have a gas pipe on the other side. Now this shows here the nozzle where the gas pipe would fit, and sliding onto that will be some sort of rubber hose that will go off and connect to the supply of gas somewhere. So how do we go about lighting this thing? First you've got your Bunsen. Oh, the elephant thing. Yes, well, in my lab where I work in here, and maybe where you are, lots of students seem to confuse or think that they look a bit like elephants, the gas taps, because they have these ears on them. And there's the gas taps like we have in my lab, and I guess you can sort of see how it looks a little bit like an elephant with the ears poking out. But at the moment, with the gas taps there, where are we? The ears are across like this, crosswise. That means the tap is off. But turn the tap there so those ears are in line with the nozzle this way, and the gas will start to flow. Sometimes they can be a bit tricky. It's often worthwhile practicing that. So what do we do first? First we're going to close the air hole. Okay, so we're going to twist the collar around here, twist that around until the air hole here is completely shut. That's going to limit the amount of oxygen coming into it and make it a safer flame, easier flame to light. Then what we're going to do, we're going to light the match or lighter, whatever we're using to light it with, light that first, hold it over our nozzle, and then we turn on the gas tap. Remember, get those ears in line with the nozzle and the gas will flow. Now you'll see the lit match or lighter flicker above the nozzle, because remembering that the thing is full of air at the moment, the gas has to come from the gas tap and push all the air out of the pipe up the nozzle before the gas hits the flame, and then it will light. So often that takes a surprising amount of time, so just be patient. Hold that lighter there. But very important, hit the match and lighter lit before you turn on the gas. You'll see two flame types. The first one is when this air hole is closed, is this yellow, tall, flickery flame, a bit smoky and sooty. That's sort of the safety flame because you can see it easier. The other flame is this clear blue one. This is the flame that Bunsen created when he had the air hole at the bottom, changing the air-gas mixture. The air hole allows oxygen to come in, and that makes the flame burn a lot cleaner and clearer. This is the flame that we use when we're heating anything in the lab. Burns hot and clear. So we're the yellow for safety and the blue for heating. And that's about it for the Bunsen burner. I hope you stay safe and enjoy using it in the lab.